Hey everyone, in this video I want to break away from the Bible study for a little bit and address this piece of paper, okay? I want to address the curvature of the earth and what we can see with our eyes. It's a very simple thing you can do. This is kind of an experiment. You can ascend in elevation anywhere on this so-called globe, and what you observe is vastly different from what should be expected living on the alleged globe earth. Say you're standing on one point on the earth, which you are. We'll just call that the top. Okay, we've sliced into this earth three-dimensional to turn it into a two-dimensional view, and from your place on top of the earth we've drawn a flat line. Okay, we know based on the curvature of the earth, based on the circumference, the diameter and the radius, we know how much curvature there should be on 1/4 of the earth, because the nature of a circle's curvature is that it actually turns back so steep that it reconnects and makes a perfect circle. So we know, you can Google it, you can find I think it's, just look for flat earth curvature chart, or globe earth curvature chart rather, and you'll see that in 1 mile there should be 8 inches of drop from where you are in any direction. Okay, at 2 miles that number is actually exponentially bigger because of the nature of the curve. The curve isn't gentle, it's not like it goes off down here. It's actually very, very sharp. It gets to 90 degrees on the first 25% of the earth. Okay, so I think the formula is for every mile squared there's 8 inches of drop. So at 1 mile there's 8 inches, and it gets bigger and bigger. What we at least can glean from this is that immediately, even in just 1 mile, and if there's curvature in 1 mile, there's curvature in half a mile, in a quarter mile. What we know is that there is instant and immediate drop in comparison, relative to this flat line. From where you are on the top, there's immediate drop off at a mile. It's 8 inches. That's a lot. 8 inches. That's a lot. That's the better half of a foot. I mean, okay. So what I'm getting at is that if you ascend in elevation on a plane, or even climbing a mountain in an air balloon, wherever you go on this earth, if you ascend in elevation, what does the horizon do? What you would expect it to do is, if it actually drops so sharply, if there's an instant negative gain in elevation, or in other words, if there's an instant drop because of the curvature of the earth, as you ascend, you should be looking down on that curvature. Do you see what I mean? But what you actually experience and what you really observe, along with everybody else on the earth, is as you ascend in elevation, the horizon actually rises to meet your eye level. Okay, it doesn't matter how high you go. You can look up on YouTube the videos of people putting their cameras on these hot air balloons or these helium balloons, and they go up like hundreds of thousands of feet, and the horizon is still level with the viewer, the camera, or with your eyes if it's you going up really high. That's impossible on the globe, okay? If the earth was a sphere, there'd be instant drop-off because of the nature of the curvature of a circle or a sphere, which is a three-dimensional circle, and you would be looking down. The instant you rise, the horizon would relatively be moving down to you, okay? It would be like this. That's what you'd see. You'd be looking down on the horizon. But instead what you see is, you can get rid of this curve here, pretend that this curve's not here, and this is the plane of the earth. Standing on the plane, you'd only be able to see so far, and as you go higher and higher, you'd be able to see further and further, and the horizon would keep rising out to you. I saw an awesome video online of somebody who they made in a computer program, in a 3D graphic kind of world. They made this wireframe plane, and as they ascended in elevation on this plane, it did the same thing that we see on our earth, is that the horizon actually kept level. Even though you could see that you were clearly getting higher and higher off of the plane, the horizon kept level with your visual source, which would be your eyes or a camera. Okay, that's impossible on the globe. I had to get this out of my system. It's been bugging me. A lot of people will tell you, no, you can go higher and higher, and the earth does curve away. It's just so big that the drop is like 0.000 whatever inches or degrees. That's ridiculous. Again, globe earth model, evolution theory, it's all unobservable. It's all mathematics, it's magic. You just have to trust them and don't believe your own senses. Whereas if you believe that the Earth is flat, you can see it with your own senses. You can tell it with your eyes and with many other senses, which I can talk about in future videos. This video is over 5 minutes long now, so I'm going to cut it short, or cut it there, rather. Yeah, I'll see you next time.